I'm Dave. I'm one of the site reliability engineers for Civo. And main reason why I'm giving this little demonstration slash talk today is I find myself writing more and more operators. They seem to be the better option for most things when it comes to SRE these days. You can codify some pretty complex logic and operations into a nice automated package. But I found that there are some difficulties debugging things in production after you've actually got it in the cluster. So here is what we're going to be talking about today, debugging operators in productions. And this is more or less in an emergency, is the context of how I usually end up debugging this way. The goals here, we're going to show the difficulty of debugging operators, specifically in production, and explain what debugging options are currently available. Then I'm going to show you how I actually debug a production operator on a machine out of the cluster using a local debugger there with a full IDE. And then we're actually going to fix the bug and deploy that into my quote-unquote production server that I have here.
Can I just jump in very quickly? Could you increase the size of your IDE font ever so slightly?
We can certainly try to figure out how OS X makes me do that.
Command plus.
That better?
Let's see. Yeah, it's certainly better.
That's better. All right, so we're also going to have a couple of side notes on how I've built my remote development environment, a little bit of how awesome Code Server is, and maybe we'll get in the fact that I have a turtle and a kitten named Kubelet, but we'll see how much time we have. So here is the scenario that we're going to be talking about today. We have a very fancy production operator that goes through, and when a custom resource is applied into a namespace, it looks for pods with a label that says, "Hello, Civo." When it finds that pod, it lists out a deployment that it is part of and reads its name out here. Now, this is a very mission critical piece of software, mind you. So you get a notification that it's outputting an empty string right here. There's no error messages or anything else, and this is probably the most challenging type of bug that I've found, where there's no real visible way to tell what's going on through the log messages. So you're going to have to start looking at memory contents at that point. Some of the issues that you're going to run into there, you don't have access to a traditional debugging system. You'd have to use something in the command line, and that's not going to have breakpointing in the way that you would expect in an IDE. As Josh has shown us from Rookout, the future is bright on that aspect. Soon enough, we'll be able to just drop Rookout in this place and be able to debug this way as well. But the other options that seem to be prevalent these days are debug containers, which are not very effective except for the ephemeral containers. And if you use an ephemeral container, you are using beta APIs, and a lot of places won't like you to do that. So another option is if you have an out-of-band machine in the cluster network that's also in the control plane network, you can simply spin up a VS Code instance in there and remotely access it through a VPN or whatever other out-of-band management that you have. So that's exactly what we have here. I have a machine that is running a VPN connection to the out-of-band management in a Kubernetes cluster. And on there, it has VS Code Server installed with the Dell Golang debugger in there, which is superb, but doesn't have a very good command line interface when dealing with code like this. So the very first step that we're going to have to do is we have to get this production operator running outside of the cluster. We can look here and see that we have this one single operator running in here. One of the easiest ways to do this is to simply scale down the deployment. So you can, let's see here, scale down the demo operator to 0, and now helps if I have the name in there. And this operator, or this dev machine, is actually running, like I said, on the same network as the production cluster. So we can run this without having to worry about any weird network issues or anything like that. And we simply start the normal debugger for VS Code, in this case VS Code Server, and we can now actually see the exact same behavior here. So we do know it's in the code and probably not an environmental issue. We're going to want to start looking around in this code, and of course you've probably used debugger before, so don't have to go too terribly deep into there, but the operator code base isn't necessarily large. It's not doing a whole lot. So what we're going to do is we're going to poke out a few breakpoints in some interesting spots here. Now, we may want to take a look at the list that is coming out of the pods here, and then the entrance to this for loop where we iterate over the list of pods, and then the actual line where we are having our issues so that we can see the general flow of this. And it's already stopped the code there on the breakpoint. And we can see that our pod list, we do have an uninitialized items section. And we can go in here and it is now populated. So we can see the data that we're actually going to be processing with in this section of this for loop. And we can look in here for the owner references. And we can see that it's a replica set, which is going to be part of the deployment, called Nginx with a random string. So we can look in the code here and see this particular object right here is where we're actually getting that deployment name that we're looking for. So we are going to very simply look up here, and we notice that Bob, our dev guy, has made a typo. And he's looking for the deployment engine. Of course, this would be dynamic if it was a real operator, but this is an easy to find and easy to fix bug. So now we can go ahead and test this. So we can simply restart our debugger. And we'll let it recompile everything and start out. And one thing that I should note is when you're running operators like this out of cluster and you restart them, you aren't necessarily going to lose work that has been applied through CR applications. They will still get processed after the operator that consumes them has started up. So there will be momentary pauses, but things still keep going on. Now we have actually gotten into here, and we are back in our debugger. So we can see that we have our list, and pods list is still empty. We populate the pods list. And then right here is where we actually output this particular log message through logger. And we can look at the it might have lost it actually in the middle of there, but we can see that once we step past, we have actually gotten that bug sorted out, and we can roll this out to production. So at that point, we're going to use some fairly standard tooling. We're going to move over into, excuse me, here, the make file. This is just a stand-in for a real CI/CD system here. And we will go make docker build, docker push. Just use the operator SDK framework to make this work. And it'll only take it a little bit of time here to build this and upload it.
Can I ask a quick question while we're waiting for it to build?
Mm-hmm.
Yeah, so this is Oheb asking, to start debugging like this in VS Code, what are the plugins that you'd need to install beforehand?
The Golang plugin.
Yeah, so the main Golang plugin includes these breakpoint handling and the sort of
Exactly.
step throughs and everything else.
This is almost entirely default. The connection that I have that enables all of this to work when I'm actually working with Civo, we have, of course, our corporate VPN. I have a dev machine, which is this big beast of a machine with its 40 processors and 128 gigs of RAM. It has a Tailscale VPN exit node set up on it, and all of my dev machine, all of my actual workstations have Tailscale on it. So when I'm coding, I'm usually using this machine, regardless of which computer I'm actually using. And the host machine connects to the work VPN and routes the traffic that way. So I have access to clusters for API calls and things like that.
But obviously, if you're not doing sort of remote cluster debugging, you'd be doing this locally, building the program locally, all that.
Yep. If you are remote from the cluster, wherever the machine that's running this is, it definitely has impacts with latency and just general network traversal because the general internet. But if you have, like I said, a jump box where you have something like this installed, and you can even, this is containerized as well, so you can start up a Docker Compose. It spins up, the dev team has access to a debugger that's in the cluster, but not in Kubernetes. And that's kind of why I built this. Just figured it'd be fun to show people.
And like that time that you showed me this before this session, and I said, like, so you're going to write a blog post on this, like, we can still count on that, right?
Yeah, absolutely. The entire Tailscale setup is optional, but it really makes it magical. I have exactly one development environment, one debugging chain, one compilation chain, one library set. Literally everywhere I go, I'm using the exact same dev machine. And the idea kind of came from Gitpod, but I didn't like Gitpod running where I didn't have access to the hardware. So I just more or less pieced this together over the last month or two, and it seems to be great. I've done all my work the last 2 months this way. And it should be pretty much done. It's compiling the actual binary now. And a couple of other nice things about doing it this way. You can use certbot to get a Let's Encrypt certificate. So your private network has real SSL, just for that extra layer of security and validity checking. All right, let's just pushing this out to the Docker Hub. And yes, my terrible operator is open source if you would like to expand on listing pods. All right, so now we can make deploy. And this is just going to go through and rebuild the deployment here. If I can hit that minus key, we'll be doing pretty good today, kids. So we'll just watch these pods as they go. Looks like it's already stopped the old one and moved into the new version, and it's gone through its health and readiness checks. So now we should be able to go ahead and get the logs here and just make sure that that particular issue we were looking for is resolved. And it looks like that has fixed the problem. So I know the bug was rather simple, but that was kind of the goal of this. It was meant to be easy to find and show you how to get the actual debugger in a place where it's useful. Coincidentally, Rookout is, like I said, the inspiration for most of the work that I've done on this. I saw what they were doing at KubeCon, and I imagine that once that is ready, integrating it with a Golang operator is going to be a real magic bullet for both SRE and dev teams. Until then, this works out pretty well. So yeah, I have a couple little of addendums though on operators specifically. The questions that I get asked about operators are, who's this for? Devs or SRE or what have you, and why do operators matter to me? Who is this for? It's for everyone. Operators are a great way to crystallize SRE operations. You simply apply a CR to a Kubernetes cluster. It goes through and does maintenance operations and gives you a report back. That's the dream that I have for SRE operators. They're a great way to collect data and expose it to Prometheus. The operator SDK has a large amount of Prometheus exporter built into it. So you can simply wire in a few metrics exporters, wire it up to Prometheus, and you can collect everything from information from a Raspberry Pi over a serial connection that is connected to a temperature and humidity sensor if you wanted to, and put that into there and have direct environment monitoring for every node in your cluster if you wanted to. Not saying it's a good idea, but that's the level of things that you can actually start piping into Prometheus just by adding an operator. We use operators that actually connect to master nodes via SSH for maintenance and configuration operations. So there's really no limit to what the operator can do on the other side as long as it just reports back as a CR status. They're a great way to automate Kubernetes in general. If you find yourself adding and deleting tons of things for different conditions, you can probably find a way to automate it in Golang and put it into an operator. And even if you don't have a need for one, they're fun and they teach you all the little intricate bits of the insides of Kubernetes. And until I myself wrote my first operator, I did not really have the full picture of how everything was functioning. And that's my TED Talk.
Good stuff. Operators are definitely interesting. We actually created an operator at Rookout as well, specifically for Java teams that were building like Spring Boot apps, deploying them into Kubernetes clusters. They were looking for a way to instrument their microservices on the fly without having to modify their containers ahead of time with the Rookout agent. So the operator actually runs in the cluster, and it automatically configures the agent for any microservice that matches a specific tag. So tons of different uses. They're very cool.
Yeah, and you can do things that you really couldn't do with just YAML and Terraform, even if you had to. You just couldn't do a lot of things. The way that you can massage new structs out of old structs is there's no YAML equivalent to that, where you can just do a partial deep copy of an entire Golang struct and have a new object that references data from an old object and then rebuild things. It's so much flexibility. So yeah, it's something that I think everybody in Kubernetes should try their hands at least once, is writing an operator. You can currently write them in Helm, Golang, and Ansible even. So if you're comfortable in Ansible and only want to work in YAML, you can YAML yourself to death with it.
Can I ask a quick, well, on behalf of Zohaib again? So he's asking the differences between the two approaches is the way I'm interpreting. Let me read the question. So in the Python application, we installed the agent to start debugging, but in the Golang application, we did not install any agent. So, Dave, could you sort of just run through slightly about what the difference in approach of what your sort of technique is? And I'll call it a technique.
Yeah, well, there's two major differences. One of them is this doesn't require any changes to the code. Number two, this also runs the debugger next to the binary itself. With Rookout, I'm not entirely certain how you guys have implemented the actual debugger attachment, or if that's done outside, but this is a true, like I said, it's a full delve debugger. So you have every single option that you would have for any Golang debugging that you could want locally, and you're actually inspecting the memory directly. When you pause a breakpoint, it does pause hard. So you can actually set up 2 or 3 terminal windows, have them watching, and then pause, make sure you have the proper memory contents, break past the breakpoint, and then watch the cluster as a whole as it interacts. I myself personally think that Rookout is going to be a great platform to build something like this that's doesn't require moving the operator outside of the Kubernetes cluster. That's the biggest advantage that Rookout has, and why I love the idea is that the binary is exactly where the binary is going to be running in production. In this case, we are moving it. So if there's environmental variables or network connections, you're going to have to do kube control port forwards. You're going to have to do a few other things to dance the dance to get that data in there. Whereas you're trading that for having that direct in-memory debugging. Rookout, you can leave it in place, add a couple of lines of initialization code, open up the UI, and you can breakpoint to your heart's content. I think the biggest thing that Rookout's going to be able to offer is being able to have, like in our case, we have, I believe, 9 operators that we are running in production that all work together. So when you apply a CR for one operator, it's going to actually generate custom resource objects for other operators, apply those. That operator might apply a CR for 2 or 3 other things like an IP address or a network, and those are going to get built and the statuses are going to return, and it's going to filter back up the chain, and that top level object is going to be marked completed, available. What I think we would be able to do with Rookout is to breakpoint the whole operator chain from beginning to end. So that I could say, I want to see what happens when I pass this out of this operator and into this operator. this point, and this point in the operator, and the transfer point between all the operators. And then you can breakpoint the whole chain and look at the entire process.
Yeah. So you're
currently,
sorry. I was going to say, like, so yes. Back to the question is what the sort of first example showed was of opening the black box, but in literal, like in medias res, like in what's actually happening in the real world application with everything, like you were saying, you know, with your environment variables, with your everything being as it is in the real world, and all you're doing is following that request through the entire chain, right?
Exactly.
Whereas what you're doing, what your example here was a bit more in isolation of just the binary, the specific Go binary that you were debugging in like solo.
Exactly. I would consider this more like a clean room debugging.
Yeah.
Where you are removing the environment. If you have questions about the environment, that's always been one of my favorite tactics, is to try to remove the problem binary or system from the rest of the environment, put it in isolation, and run it there. Sometimes it's just an environmental variable or some weird kernel issue in this particular subversion that is on that machine. And that's what this does offer, which has its own distinct advantages. You can clean up the environment, you can meticulously groom that and make sure it's exactly what the specifications say. Run it. If the issue goes away, then you can go back and start debugging the actual production environment.
Yeah. So like these are complementary approaches. Like that's the main thing that I'd like to really stress here, is that one isn't better than the other. One isn't, you know, they're doing different things around the same domain.
Yeah, exactly. I feel that the combination of the two approaches, it really doesn't leave many dark corners that you can't get to. You know, this is a lot more involved in a complex operator, and it has some performance hits that are going to come in play, and it can get weird sometimes, but the advantages that it have make dealing with that quite worth it. And yeah, so I hope to be in the beta program of the Rookout Golang debugger pretty soon, because
absolutely.
I want to tie the two together.
There you go.